Okay. So pretend we're playing a casino game, and then I offered you the chance to flip a coin, right? And if you get heads, you get $10. But if you get tails, you get no money. So then, how much money do you think you'd pay me to play this game? If I told you you could only play like once.
$3.
Okay, so that's pretty good. So you won't pay like $10 to play this game because like that doesn't really make sense.
50-50, yeah.
Yep. So then $3.
Can I technically pay 5? Well, yeah, but it's once. But it's once, so I'd better hedge the risk, I guess.
Yeah. So pretty much, okay. Would you pay, let's say, $4 for this game?
Maybe, yeah.
And do you think you'd go as high as like $5?
No, not really.
Okay, so what do you think?
That's the point when it's not worth it. Everything after 4, I think, in my estimate.
Everything after 4. Okay. So then, if I change the rules slightly, right? If I said, okay, it's the same rules except you get $100 if you flip heads, would you pay $40 to play this game?
Once. Once.
Yeah,
well, again, I would say $30. 40, maybe if I'm in the right kind of mood.
Okay. Yeah. So this one.
That's if it's once.
So when you like think about this, are you like calculating sort of just the probability of it?
Approximating. Well, the probability is 50-50.
Yeah. So are you calculating like how much you'd win, or is it mostly like intuitive at this point?
Sort of intuitive, yeah.
Okay. So then, what if I gave you the chance to play like an infinite number of times, or as many times as you wanted, in that $100 example? What? Yeah. So if
Like
you could play,
the limit would be 50, I think. If we play infinite amount of time.
So
the probability is 50-50. Then $50, $400 is the limit.
400 or sorry, $400.
No, 50.
$50
for 100.
Yeah. Okay. So what do you think is the difference then, like, between offering you like to play infinite times versus like offering to just play once? Because when it was just once, you said like you'd probably pay 30 to 40, but after like if you have the chance to play like
well, because
as many times as you
because
want.
in infinity it would be 50-50. So if I play once, it's just one of the 50s. It's just one outcome. But then if we expand it to infinity, then so far as I bet less than $50, I will get some sort of profit out of it, depending on the sum I pay.
I see. So you're pretty much saying like anything less than 50 is okay.
If it's infinite.
Yeah. Okay.
Yeah, I wouldn't of course try to pay less.
Yeah.
Just so I could get more in infinity.
Okay. So then, okay, that's pretty good. So you've already got the idea of like thinking like in terms of infinity. So then, if I offered you a different scenario, let's say you still have the coin, right? We're still playing the coin game. If you flip a heads, you get $1. Now you keep that $1, and then if you flip a heads again, you get $2, and then it goes 1, 2, 4, 8. So just keep multiplying by 2, right? But the moment you get a tails, that game ends, and then it stops. But you keep all the money you've won, like up to that point, right?
Yeah.
So then, in that case, okay, how would you go about, like, how much do you think you'd pay me for that game? Assuming you could play, as many times as you wanted.
Less than 50 cents, I think. Just so it's 50-50 again. So the limit I can bet is 50% of the first win.
But then, okay, so you think it's 50% after the first.
Well,
coin
you
toss.
you can definitely add some premium if you think you can get the second head. But it just depends on how much you want to risk it.
So
But
then,
technically, yeah, I think you can add some premium because there is a possibility of getting more if you consistently get heads.
yeah. And what do you think about that possibility? Like, do you think there's a good chance of you like consistently getting heads
No, of
and then
course
earning a lot of money?
No, of course not.
Okay. So then, is 50 cents? Would 50 cents be the highest you could go?
What is it? Stale. Whatever.
So would 50 cents be the highest you're willing to go?
Slightly above that.
Slightly above?
Maybe up to 60. But I
So-
don't know.
Okay. So is your main reason, so what's your main reason for not like wanting to bet higher for this?
Just less of a risk, I guess. Yeah.
Is that because you don't think you could like, you don't think there's a good chance to win your money back in the because I'm offering you like double every time. So, but then do you think there's like a good chance of that?
Yeah, that's why I'm saying there is a premium. But the possibility of every consecutive head diminishes pretty significantly.
Yep.
So that's why this premium isn't too high.
So how much do you think like the probability of getting a heads like diminishes like every time? So it's like what are the chances of me getting like 7 heads or something in a row?
I think we multiply it, right? So put it in powers, basically.
Yeah.
So the first tally would be 0.5, then 0.25,
Yep.
and then
Yeah.
0.125,
And so on.
exactly,
Yeah.
and so on.
So the probability is like decreasing, right, as you go higher number of heads. But the prize money is also increasing, right? So going back to that example with one coin.
But after we get 0.125, then what's the next one?
So that'd be something like 0.06.
Well, it would be, always would be half.
Yep. So
But then we get the win increasing by 2 times.
by 2 times, right? So like
So I think they cancel out in a way.
So then if they cancel out, then like what do you think that does to your like expected winnings, I guess?
They don't change, right? Like we extrapolate them to infinity.
So yeah, so a good way to think about this, I would say, is that, so going back to that coin flipping game with the $10, right? So that was me offering you $10 if you get a heads, but nothing if you get a tails. But then, like, let's pretend I give you a dice instead, right? And I said that if you get a 6, you get $30, right? But then if you get any other number, you don't get any money. Then in that case, how much do you think you'd pay me for that game?
I get $30, correct?
Yep, if you get a 6.
The limit should be 5 because the chance is 1 out of 6.
And that's true regardless. Do you think if I said, oh, you could play as many times as you wanted?
For one, if I pay once, I can play unlimited time, or I could have to pay for each one, but I can play unlimited times.
So you have to pay each time, but you can play unlimited times.
Well, as long as it's below 5, I will get some money out of it if we expand it to infinity. Yes.
And that's like the same answer pretty much that you gave for the coin, right? Which is well, it was also 5.
Yeah.
But here you only had like 1/6 of a chance.
Well, that's why I don't pay half. I pay 1/6 at most.
Yep.
So you hedge the risk by dividing the winning sum by the probability of winning it.
Mm-hmm. Okay.
And that's how you get the limit. As far as I know, I'm not a mathematician.
Yeah. So this is pretty much kind of like the way you try to think about the other problem with the the $1, $2, $4 one. Is that your probability of getting it is like decreasing, but the chance your money is also increasing at a similar rate.
Mm-hmm.
Mm-hmm. However, that one is like sort of outside the scope a little bit of 31B, so we won't go too deep into that because that one actually that one actually goes to infinity, the expected value, but you can't actually make money off that. Like, it's not that you get infinite money because like the variance also goes to infinity, but that's not really part of 31B. The part that's in 31B is that you just got to think in terms of like infinity.
Mm-hmm. Yeah.
Okay. So we seem to have a bit more time. Are you familiar with the geometric
Of course,
sequence?
Yeah. Mm-hmm.
So if I told you I start with a half, right?
Yeah.
And I add a quarter, I add an eighth.
Wait, a third?
Well, a half.
Isn't it? Okay. So a half, then a fourth.
A fourth.
Not a third.
Not a third. So plus an eighth, plus a fourth, plus an eighth, plus a 16th. What do you think that will end up equaling? Like, I just kept going.
1.
1. Yeah. So this is like basically what a geometric series is, right? You start with a certain number and then you divide it by like a fraction, like a ratio, and then you just keep adding. So actually, do you know the formula for how to work
I
out?
do not. I just remember that particular problem from SAT Math Level 2.
Mm-hmm. Yeah, so that's good. So most of these, like, sometimes they're like quite intuitive, right? But then occasionally it's like a very weird thing where it's like, 1 on 5, and then it could be like 1 on 15, 1 on 45.
Yep.
So it's like going down in thirds, but you start with like 1 on 5. And in that case, it's going to be hard to figure out, right? So then this is sort of a picture that we drew.
You drew.
That I drew, yes. It's a little hard to see, but it's pretty much a whole bunch of squares
Should have used a
as
marker.
diminishing. Yes, should have used a marker. But it's pretty interesting. So basically, the square, right, is the biggest square has a side length of 1. And then the next square is scaled down by a ratio of r.
Mm-hmm.
Okay, so the next one is r.
Yep.
The next one is r squared.
Yep.
Right?
Yep.
And then it goes so on, so on, so on. Yep. And so the question is, what is this length? Like, what is the length on the bottom of all the squares added together? So I think like this one's a little bit tricky if you haven't seen it before, but I'll give you a hint. It's using similar triangles to figure it out. So this is like a 31A.
All of those triangles on top, the ones that are on top or not.
So a hint is that all of these triangles, right? Like each one of them is similar to this like big one.
Yeah.
So similar triangles is something that you've gone over in like 31A stuff, right? So this is good because this is kind of using 31A stuff to prove 31B stuff. So if you take a look at this picture, right? And then knowing that this triangle is similar to the biggest triangle, do you think?
But they're also similar between each other.
Yes, they are. Except the main ones you look at are this one and this one. So the top triangle and the giant like bottom triangle.
Yep.
Right. So in that case, is there
Can you just
this?
explain this to me? We're running out of time.
So this side is the side that you don't know, right? That you're trying to find out. But you know pretty much like all the other 3 sides. Like you know this side, you know this side, and you know this side. So do you remember how like similar triangles were?
Yeah, I know. Yeah, I remember.
So then, would you be able to write out an equation for this side? Like, if you set this side as like x.
Well, yes, I would be able to if I was interested in it and had time.
Okay, so pretty much the way that it's done, right, is that this shorter side divided by the longer side is equal to this shorter side divided by this longer side. So this divide that is just 1 minus r, right? And then 1 divide this would equal 1 minus r. So then this side would actually equal 1 divided by 1 minus r. And the thing you end up getting is 1 over 1 minus r, which r being like the ratio we're going down by every time. And then you notice how we have a 1 on top? The actual formula has like an a on top, but then we have 1 because we started off with the side as 1.
A is equal 1.
And we could have started off with like any number we wanted.
Yeah, of course.
And it would still work. And so pretty much like this is an example of how like 31a like
translates into 31b.
Like you can use something from 31a to prove another thing from 31b. But okay, I think for now we might end the interview here. But I hope this has helped or like at least been sort of interesting for you to think about gambling and geometric sequences. Okay, but all right, thank you for your time.
Yep, thank you.
And